Question number 6 of exercise 15.5. Malik wants to estimate the width of a river which has parallel banks. He starts at point A on one bank directly opposite to a tree on the other bank. This is the tree. He walks 80 meters along the bank to point B, okay, from here till here, and then looks back at the tree. He finds that the line between B and the tree makes an angle of 22 degrees with the bank, this one. Calculate the width of the river. Okay, we need to find out the width of the river. For that, what we need to do? We need to use the tangent ratio. So tangent of the given angle, that will be equal to the opposite side, that is this A tree, like this distance. Let me call is like as O. So this would be O divided by the adjacent side, that was the opposite side, divided by the adjacent side, that is 80. So this O is actually equal to 80 times tangent 22. So that will give us, using the calculator, a value that is 32.3 meters. So O, that is the opposite side actually to this angle, and that is actually the width of the river. Width of the river is 32.3 meters. Okay, that completes question number 6. It is then question number 7. The right angle triangle ABC has angle BAC equals to 30 degrees. This one, taking the length of BC to be 1 unit. This is taken as 1 unit. Work out the length of AC. This is what we need to find out. That means we need to find out tangent of 30 degrees, that is equal to opposite side, that is the side BC, divided by the adjacent side, that is AC. From our calculator, we can find out that tangent 30 is 0.577. So BC side divided by AC side. So this will yield an answer that is to be calculated like if you calculate this side BC to be 1 unit, what is the length of this side AC? That is X. So we can calculate it as 1 equals to X times 0.577 and x will be equal to 1 divided by 0.577. That will give us 1.73. That means the length of AC is 1.73 times the length of the side BC. Okay, then for part B, use Pythagoras theorem to obtain the length of AB. Okay, we need to use the Pythagoras theorem and we need to calculate the length of the side AB. Since we have got AC to be 1.73, and the length of BC was 1. So using the Pythagoras theorem, we can calculate it as square root of 1 square, which is 1, plus square of 1.73 actually. So that will give us the required answer. That is, if this is x, for example, or I may not be using the letter x, let me use the hypotenuse. H squared is equal to square of 1 plus square of 1.73 and whole square root. When you just vanish this square of h, and now this will give us, using your calculator, a value of 1.998. So that is equal to h equals to 2. So the value of the hypotenuse is 2. So that completes question number 7. Question number 8 is, the diagram shows a ladder leaning against a brick wall. If the angle between the ladder and the floor is 82 degrees, like this, and the ladder reaches 3.2 meters up the wall, here, find the distance d meters of the bottom of the ladder from the bottom of the wall. This distance we need to find out. So using again the tangent ratio, tangent of 82, that is equal to 3.2, which is the opposite side, divided by the adjacent side, that is d. So cross multiplying them, d will be equal to 3.2 divided by tangent 82, which is 3.2 divided by tangent 82. So the value of d is 0.449, or that is equal to 0.45 meters. Then finally it is question number 9. A person at the top of a building can see two bus stops A and B at ground level. The top of the building is 60 meters vertically above ground level. Like for example, this is a building. The top of the building is 60 meters vertically above ground level. So this height is 60 meters. The angle of depression from the top of the building to bus stop A is 25 and the angle of depression to bus stop B is 20 degrees. So this is one angle and this is the other one. So this is 25 and this is 20 degrees. Then, assuming ground level is perpendicular to the building, like this, we need to have a right angle triangle like this. How far apart are the bus stops? We need to find out this distance. This is how much is the distance between them. So for this smaller triangle, let me have this distance to be denoted by y. So I can write down tangent of 20, that is 60 divided by y. So the value of y will be equal to 60 by tangent 20. Which is 164.85 meters. Okay. Then let us use the larger right angle triangle now. This one. So tangent of 25 degrees, that will be equal to 60 divided by x plus y, because now the base is this distance plus this distance. So we can substitute the value of y at this place, or tangent 25 will be multiplied by x plus y. And let me multiply it and let me open the bracket using the distributive property tangent 25 plus y times tangent 25, that is equal to 60. So from here, x tangent 25 will be equal to 60 minus y times tangent 25, that is 60 minus the value of y was 164.85 times tangent 25. And then with this whole expression, I need to divide tangent 25. So from the calculator, we can find out that the value of x, or the distance between these two bus stops, will be 36.18 meters. So this distance is 36.18 meters. The distance between two bus stops. This one. So that completes question number 9 and this exercise 15.5.